4-2, adding and subtracting real numbers. I will tell you that this is the area of integers that people have the most problem with, and I'm going to try and make it as simple as I can for you. So, let's just start with easy. 3 plus 5, 8. Super easy, both positive numbers, exactly the same. So what I want you to think about, go back to that, we know now negative means opposite, okay? I want you to really keep that in your head because I think that will really help you with all of the integer stuff, okay? So, now we've got negative 3 plus negative 5. So all we did was take these numbers and we have the opposite of 3 and 5, which are negative 3 and negative 5. So if you just ignore those negatives for a minute, we know that 3 plus 5 is 8. We know the opposite of positive 8 is negative 8. If you're looking at that on a number line, right, let's go back to our vertical number line. You would start at 0. You would go down 3 and then down another 5. Right? So that means that you went down a total of 8. Okay? So, now let's think about 3 plus negative 5. So there's a couple ways you can do these. And I really want you to have a good grasp on integers so it'll make all of algebra, all the way through math, so much easier for you. So, think about what this is saying. This is saying 3 plus, but this means the opposite. So I'm not actually adding 5, I'm actually subtracting 5. So sometimes you will see double signs like this. I actually don't really prefer double signs. I want you to just say what it is doing, and that will help you kind of simplify all of your integers. So instead of adding it, this tells us it's doing the opposite, so it's really 3 minus 5. Okay? So if you think about a number line, it started at 3, but then it had to go down 5. So it ends up at negative 2. It had to go 2 steps below 0. Okay? So, now, you can switch this around. You can actually write this as 5 minus 3, which is really easy, right? And then you have 2. Okay? Another thing I want you to think about is that when you see positive, it means something is increasing, right? If you have positive $10 someone gives you, your money's increasing. But if somebody takes away money from you, then clearly your money is decreasing. If you just think about it like that, it'll make a lot of this so much easier. Okay? So for example, I have a 7.4 and then it's decreasing by 9.5. So it's decreasing by more than it's starting at, right? So what you can actually do is just leave that negative off there for a minute, okay? And just find the difference between those two things. So you have 9.5 minus 7.4, 5 minus 4 is 1, put your decimal down, 9 minus 7 is 2, but we know that it's the opposite of that. We have more negative than we have positive, so our answer is going to be negative. Okay? Same thing here. We start with a negative 2, and then we increase it by 4, because we're really good at absolute value now. We know it would take us 2 to get back to 0, and then I've got 2 more. So 4, and if you look at it this way, you could rewrite this as 4/5 minus 2/5. So somebody out there is saying, well, Ms. V, you didn't put a plus in front of this. Well, you can, right? Because this positive is associated with that 4/5, and the negative is associated with the negative 2/5. And all it's saying is you have 4/5, it's decreasing by 2/5. So the answer is 2/5. Okay? So think about what this is doing. If you started at 0, then you decreased by 3/8, and you decreased by 2/3, all you're doing is going down, right? You're decreasing, and then you're decreasing again. So we can use bow tie method, but now we know our answer is going to be negative. So my advice to you is put the negative down, put your fraction line down. You already dealt with the sign. You don't have to deal with it again, okay? Let's use our bow tie method. So 8 times 3 is 24, and then we've got 3 times 3 is 9. Yes, you can use bow tie for integers. And 8 times 2 is 16, and we're just going to add those together, because we already know when we do that, our answer is going to be negative. Just like that. We know it's the opposite, because these were the opposite of positive 3/8 and positive 2/3, so our answer is the opposite of what our answer would be if they were positive. Simple. Okay? Got an empty space there, but that's all right. So let's deal with this. So another way that you can think of, I'm going to use it for this. I have some kids that like it this way, and they will make a little chart, and say, okay, I've got positives and I've got negatives, and it helps them figure out which side is winning, essentially. Okay, so in this case, you've got 3 on the positive side, you have 11 on the negative side, and all you have to do is ask yourself which side has more, which is clearly the negative side, and by how much. Well, 11 is 8 more than 3, so it's got 8 more, and the negative side wins. So it's negative 8. Okay, that's another way you can do that. So now I've got the absolute value of negative 8, which I know is going to be positive 8. Okay? Same thing here. Remember, adding, you can put in any order that you want. So you can definitely rewrite this, change it to an easier problem. A lot of math is exchanging one thing for another. Okay? So say you owed your mom $5, but then your grandma gave you 30, right? But you don't end up having $30 at the end because you have to pay your mom back the $5, right? So you have $30, but you got to pay her back 5. So you do have $25. Square root of 25 means what number do you multiply by itself to get 25? And the square root of 25 is 5. Okay, I'd like you to try these two on your own and then come back and check your answers. Alright, so let's check and see how you did. So the easiest way to deal with adding two negative numbers is just ignore the negative for a minute, okay, and then just add the numbers up. So I have 2.3 plus 14.8, I get 17.1. Now both of those are opposite. They tell me they're doing the opposite, so the opposite of 17.1 is negative 17.1. Easy, okay? Now, when you get to this one, it's a tiny bit more complicated, but not really. Still use your bow tie method, right? That negative is going with this fraction over here. So I know whatever I would get, so let's say it wasn't there, right? And I used my bow tie and I got 7 times 3 is 21, and then 4 times 3 is 12, but it's the opposite of that because of this little number sitting right there. So it's negative 12, and then 7 and 1 is 7, positive 7. So now I've got negative 12, positive 7 if you use your little chart, right? You've got 7 on this side and the positive, 12 on that side. Well, if you have $7 but you want to buy something that's $12, you don't have enough money, right? So you've got negative 5. So you have negative 5 over 21. We'll do a lot more practice with these, so don't worry, okay? You're going to be excellent at these by the time you leave me. All right, couple really quick properties of addition, and they're super simple. Commutative property of addition is just that it doesn't really matter what order you add things in, okay? A plus B is the same thing as B plus A. I say if you have a sandwich and chips for lunch is the same as if you have the chips in a sandwich, right? So 1 plus 3 is the same thing as 3 plus 1. Easy, right? We know they both equal 4. Everything's fine, okay? Associative property is the same thing, but happens when you have more than 2 items that you're adding together, and it's how you group them. But even no matter how you group them, they will still. So let's say we have 3 plus 4 plus 1, and we know that equals 3 plus 4 plus 1. But let's say that I group them like this. Okay, so we haven't talked about order of operations yet, it's coming, but we can just make this a smaller number here. So 3 plus 4 is 7, and then add that to 1, and we know that that's 8. And we know 4 plus 1 is 5, so 3 plus 5, well, that's also 8. So it just says that you can group them in different ways, but when you're adding, and it applies to multiplying too, both of these properties apply to multiplication, you will get the same answer. Okay, quick, easy. Okay, before you do anything else, I would like you to take a nice big marker, and right above subtract, I would really like you to just think about the word combining. When you're adding or subtracting integers, that's all you're doing. You're just putting some integers together. You're combining them. And I think when you get hung up on the adding and subtracting, it makes things a lot more confusing. If you just think about, I'm putting two numbers together, what is my end result? Okay? So when we are quote-unquote subtracting, you're doing the same thing. Remember that the sign is always in front of whatever number it's doing. Okay? So I have 3, and then I'm subtracting 5. So think about money. If you have $3, you want to spend $5, you don't have enough. You're short by $2. Okay? You don't have $2 change, right? The opposite would be if you had 5. Let's flip the signs on these. If you had $5 and you spent 3, you would have 2 left over. But we switched both of those signs. So your answer, since your original problem is the opposite, your answer is going to be the opposite. Okay? So here's what we've got going on here. So 3, this is telling you to subtract. This one tells you to do the opposite. So the opposite of subtracting is adding. Okay? So, and let's think about that on a number line, right? So you start at 3, let's say you're at 3 right here, and then it says decrease. Oh wait, don't decrease. Go up by 5. You're going to end up way up here at 8. Okay? So that's 8. Okay, and again, if you've got two negative numbers, just drop the negatives for a minute. If you combine a 3 and a 5, you would get an 8. So since you're combining a negative 3 and a negative 5, you're going to get the opposite of that, which is negative 8. Okay? We got the same thing going on here, so that's a duplicate. Don't worry about that. Okay, so again, this is telling you to decrease. This is telling you to do the opposite of that. So it's actually increasing. So it's 12.4 plus 3.5. Easy, easy. 4 and 5 equals 9. Put your decimal. 12 plus 3 is 15. Easy. Okay? So we can do the same thing here. This would be the opposite of 2 ninths and 4 ninths, which if we added that up, we know we would get 6 ninths. But they're both the opposite, so it's just negative 6 over 9. Okay? So let's go down to some other examples you've got going on here. I think it's easier to put these into mixed improper fractions. Okay, so again, you've got 3 and 5, but you have the opposite of that. So if you combine a 3 and a 5, you get an 8. The opposite of that is negative 8. If you think about the combining thing, it's really pretty easy that way. So you're combining a 12.4 with a negative 3.5, but this is telling you it's the opposite of that. So you're actually combining it with a positive, with addition, 12.4 and 3.5, which would give you 15.9. Okay? And here you've got opposites again. So if we just combine positive 2 ninths and 4 ninths, we would get 6 ninths. The opposite of that is negative 6 ninths. Okay? Let's go down here. We've got 2 and 3 fourths. I'm going to change this into an improper fraction. 2 times 4 is 8, plus 3 is 11 fourths. I'm going to change this to something over 4. And I know I can do that by multiplying top and bottom by 4. So 4 is the same thing as 16 fourths. And we're subtracting that. I know that if I only have 11 and I want to subtract 16, I'm going to end up with a negative number. So that's going to be negative 5 fourths. Okay? And here again, we've got the opposite of subtraction, which is going to be addition. Absolute value of 3 plus 14 would be 17. Square root of 39 minus 30. It's pretty easy. Square would be square root of 9, and square root of 9 is 3. Okay? Is there an associative property and a commutative property of subtraction? No, it doesn't exist, right? Exist technically, I'm going to say. But if you think about the combining idea instead of adding subtracting, you can still apply the same rule to that. Okay, so what about irrational numbers? So let's just think about that for a second. So we can definitely add two rational numbers together, and we know we get 2 and 4/5. When you're adding a rational and irrational, the only way you could do that is if you converted this to a decimal. Okay, because these do have values. There is a square root of 3. It's just not a whole number. There's a square root of 7. There's a square root of 2. If you're adding a rational and an irrational, or two irrationals together, you're going to leave it in this format, okay, unless you change it to a decimal. So you're just going to leave it this way. Leave unless convert to a decimal. Okay, that's 4-2. Good job.